Good morning. Today we are going to discuss about the fundamentals of network to have better understanding about the principles of Internet of Things. Basically, the traditional OSI model has 7 layers. They are physical, data link, network layer, followed by transport, session, presentation and application. We all know that in the physical layer, we have the cables, connectors, the hardware associated with that, over which the data link layer, which contains the protocol that is more specific to the data link layer for forming the frames. Ethernet 2 is the popular data link layer protocol for the TCP/IP networks. Over the data link layer, we have the network in which the Internet Protocol IP version 4 or version 6 will play the major role, along with the Internet Control Message Protocol and a few more. Over the network layer, we have the transport layer. The predominant protocols in the transport layer are TCP and UDP. In most of the cases, the top 3 layers, they are the session, presentation and application layers, will be collectively called as the application layer, in which we can see the popular HTTP, SMTP, FTP and so many popular application layer protocol. So with this introduction about the 7 layers of OSI model, we move further to the connectivity protocols. There will be a separate session on the connectivity protocols, but to give some fundamental idea about the various connectivity mechanisms that are adapted in the IoT, we discuss about few of them. First, we go to the category called PAN, Personal Area Network. The personal area network has a Bluetooth, Zigbee and a few more protocols that belong to the personal area network connectivity, followed by the local area network, which may be a wired Ethernet connectivity or wireless Ethernet connectivity, over which we have a metropolitan area network, MAN. For example, we can have IEEE 802.16 WiMAX as a metropolitan area network, in which we have the one more large coverage area network called wide area network, which is defined through IEEE 802.20, that is wireless mobile broadband and wireless access. So with this in our mind, we will have a separate session on the connectivity mechanisms. We move on to the next thing called the various communication technologies that are adapted in the IoT. The popular thing is Bluetooth, iBeacon, Bluetooth low energy or Bluetooth smart, followed by the Zigbee, the short range and low power protocol, followed by the Z-Wave, which is predominant in the smart home applications, followed by near field communications and the radio frequency identification, RFID, Wi-Fi and cellular technology like 2G, 3G, WiMAX, long-term evolution, mobile broadband wireless access and the popular cellular technologies for the IoT, NB-IoT, that is narrowband IoT, extended coverage GSM. Even you can also make use of the power line communications, followed by the wired Ethernet, as well as the non-cellular communication technology falls under the category low power wide area network called LoRa and Sigfox. And many more technologies are available for the communication technologies for IoT. Now, the very important thing is there are different addressing schemes used in the networks, and if you particularly go to the transport layer, the port number, which is nothing but a 16-bit unsigned number, is the most important addressing scheme in a network communication. An example is HTTP has a port number 80, whereas HTTPS, that is secured HTTP, will have a port number 443. When you come to the layer 3, that is the network layer, we have the addressing mechanism called IPv4, which is a 32-bit number, and IPv6, which is a 128-bit addressing scheme, followed by the data link layer, which is having another interesting address called physical address or burned in address or hardware address. We technically call them as a media access control, that is MAC address, which is of 48-bit flat addressing scheme. So compare it to all other layers, the transport layer with the port number, network layer with the IP address, and the data link layer with the MAC address, are the three different addressing schemes that are adapted in the networking that should be understood by everyone to have better understanding of the IoT communication technologies. Look at this picture. We have a client machine with an IP address IP1 and a server with an IP address IP2. And you have two or more connectivity sessions. The first session is having a port address 5000 in the client side and port address 80 in the server side. There is another connection that is with the port address 25 in the client side and the port number 25 in the server side. So the first connection is for the web server and the second connection is for the email server. Now an important concept called socket comes into play. What is meant by socket? The socket may be either TCP sockets or UDP sockets. The socket is nothing but a combination of an IP address with the port number. So IP address together with the port number will give you the socket, and the socket will be in the client side as well as in the server side. So a connection between the client socket and the server socket will be established to have smooth transaction between the client and the server. So on every TCP IP network, every device must have an IP address. The IP address identifies the device or the computer, even your mobile phone. So the IP address alone is not sufficient for running network applications, because simultaneously a computer or a mobile phone can run multiple applications or service. Therefore, to identify a particular application or a service, in addition to the IP address, you need one more address that is called the port address. That is why the IP address along with the port will be the part of or the components of a socket. So in the client side you have an IP address and port number. In the server side you have another IP and port address. So putting together you will have a client socket and the server socket, and a connection will be established between the client and the server socket. So using the port, you will be able to run multiple services or applications in a single computer or a single mobile devices. I hope you have some idea about what is the need of IP address and port address to form a socket. Fine. Now we will have some detailed discussions about the port number. So port number is basically an unsigned 16-bit number, so that its value ranges from 0 to 65,535. And the port numbers will be divided into three categories. The port number 0 to 1023 is called well-known port number, and it is assigned to the popular server services by the Internet Assigned Numbers Authority, IANA. For example, you all know that the port number 80 is for Hypertext Transfer Protocol and the port number 25 is for Symbol Mail Transfer Protocol. Apart from that, the port number from 1024 to 49151 is called the registered port, and this is used for registered services by the IANA, and it should be treated as a semi-reserved. That means the user written program should not make use of these numbers. It is used by the registered services. And apart from this, the port number from 49,152 to 65,535 will be used by the client programs, and the client applications are having the freedom to make use of any one of these port number from 49,152 to 65,535. They are also called ephemeral ports The 49152 to 65535 is the port number that is assigned by your operating system to any one of the client applications or services, mobile phone or in your computers. So now browsers, we move on to the one is looking at Google website, so and another is the looking TCP at socket website. Is nothing but so a combination of connection IP address plus port. Your each end of the connection IP1 plus port number 60. So imagine you are sitting on a PC at your as home, a client socket, and Google IP2 plus port number 80 as the server socket. So the combination of IP1 plus 60,200, the socket on the client computer, with IP2 plus port number 80 on the destination socket on the Google server will constitute the first TCP connection. The second TCP connection is to the Yahoo server, and that will contain a combination of IP1 plus 60,401 as your port number, with IP3 and port number 80 on the destination socket on the Yahoo server as your TCP connection 2. So the TCP connection 1 and the TCP connection 2 are differentiated by any one of the parameters, that is the source IP, source port, destination IP or destination port. A difference in any one of these four parameters will differentiate one TCP connection from another TCP connection. Therefore, keep in your mind that to differentiate one TCP from another TCP connection, at least one of these four parameters should have a different value. The next thing is, suppose if you want to see how many TCP connections were established in your system currently, you can type netstat in your command prompt. You will be able to get a list of TCP connections currently established in your machine. So from this diagram, you can understand that currently in my laptop, I have 5 different TCP connections. For example, if you look into the TCP connection 2, my IP address is 192.168.43.169 and my port number is 51179. So you can understand that all my client applications are having the port number greater than 49,151. So in the foreign address, that is in the server side, the IP address is 52.111.241.0 with a port number HTTPS, which is nothing but 443, and the connection state is established. So from that, it is very clear that whenever I make a new applications or service, a new TCP connections will be established, and through the netstat command prompt, command applications, I will be able to find all the active connections currently established from my laptop or from my mobile device. So with this, we got a clear idea about what is called the port number, IP address, as well as the socket. And in a nutshell, if you go to any TCP connections, you can understand you need a source port number and the destination port number, along with the sequence number, acknowledgement number, and the flag. In the UDP, also you need a source port number and the destination port number. You can see the sequence number and acknowledgement number is missing in the UDP because UDP is a non-reliable protocol. There is no reliability. So the sequence number and the acknowledgement number in the TCP will provide reliable connectivity mechanisms. Now coming to the IP, which is the layer 3, you can see there are two more things, that is the source IP and the destination IP. So look into that. The layer 4 will contain the port number as an addressing scheme, and the layer 3, that is IP layer, will contain the source IP and the destination IP as an addressing scheme. So with that, now we move on to the next slide that will give a brief idea about one of the application layer header, that is the HTTP request and response header. If you look into that, in the TCP request header, you can see that there is a HTTP method, the URL, the version number, followed by the various header field name and their values. And at the end of the HTTP request, you can see there is a carriage return line feed, carriage return line feed. That is 2 consecutive carriage return line feed will marks the end of the HTTP header, which will be followed by the entity body, which is nothing but the message, the payload of your HTTP message. The next slide will give you the HTTP response message, in which you can see that the version number followed by the status code. All of you know that the HTTP status code 200 is very popular, that is okay, and the HTTP status code 404 is called the page not found, followed by the various header field and their values. And to mark the end of the HTTP response message, you have two consecutive carriage return line feed, carriage return line feed. Now the question will come into our mind, where is my layer 4 header and layer 3 header and layer 2 header and trailer? Fine. So this entire layer 7, or you can say layer 5, 6, 7, that is the application layer together, will act as the payload for the layer 4. So the payload from the application layer along with the layer 4 header will act as the payload for layer 3 and so on. This is called the encapsulation in the transmitting side. Now so far we had discussed about the HTTP, that is the application layer header. Now we move on to the layer 4 header. In the layer 4 header, you have two mechanisms. One is called the TCP header, which is minimum 20 bytes, and another is called UDP header, which is 8 bytes. So in this TCP header side, if you look into that, you have a source port, you have a destination port, followed by the sequence number, acknowledgement number, and a few more fields. Whereas in the UDP header, you have only 16-bit source port, 16-bit destination port, and there is an absence of sequence number and the acknowledgement number, from which you can have a clear idea that the TCP is a reliable connection mechanism, whereas UDP is a unreliable communication mechanism. So we already discussed about the application layer header, followed by the layer 4, that is the transport layer header, and the next is called the layer 3 header, which is nothing but the IP header. So in the IP header, if you look into that, you have a version number, you have the IP header length, and the most important thing is the source IP address followed by the destination IP address. So if you look into that, there are 5 layers, 1, 2, 3, 4, 5. So 5 into 4 bytes, 20 bytes IPv4 header is there. The remaining thing is called the payload. So far we discussed about the application layer header, the transport layer header, and the IP header. Now when you go to the command prompt and if you type ipconfig space /all, you will get some information. From that information, we are going to get another interesting addressing scheme called physical address. That is nothing but the layer 2 address. So when I type ipconfig space /all, I will be able to get much more information. Along with that, I got a physical address, that is nothing but the MAC address, and the MAC address is nothing but a 48-bit address that is separated by a hyphen, and each is having 8 bits. So totally putting together, you have a 48-bit MAC address that is also called as a burned in NIC, that is network interface card ROM. So the next thing is, out of this 48-bit address, if you look into that, there are 24 bits plus 24 bit. The first 24 bit is called organizationally unique identifier, and the next 24 bit is called network interface specific serial number. In my computer, when I type, I am able to get 00265E as my first 24 bits. When I type this into the internet, I am able to understand that this is the vendor ID and the vendor name is High Precision Industrial Corporation Limited. So from that I can understand that my laptop has a NIC manufactured by the High Precision Industrial Corporation. And the next thing is layer 2 header. So when we discuss about the layer 2 header, we will get a complete picture of all these 7 layers in the traditional network. So in the layer 2 header, so if you look into the payload, you can see that the payload is having a minimum 46 bytes and a maximum 1500 bytes. So the payload is nothing but the packet or the datagram from your network layer. So the network layer will provide the payload to the data link layer, and the payload will contains a header and a trailer, and the header will be of, basically it will contain 6 bytes MAC destination address, 6 bytes source destination address, 2 bytes type of the frame, putting together 6 plus 6 plus 2, 14 bytes in the header and 4 bytes in the trailer. The trailer is nothing but your CRC checksum. In addition to the 14 bytes in the header, there is an optional 4 byte field that is called the VLAN tag, that is defined through 802.1q, that is virtual LAN tag. By default, I can say 14 bytes header and 4 bytes trailer. Therefore, by adding 18 bytes to the minimum payload 46 bytes, I can say the minimum frame size will be 64 bytes and the maximum frame size will be 1518 bytes. And in addition to the header, you have 8 more bytes, that is called 7 bytes preamble and 1 byte SFD, that is start of frame delimiter. That preamble will contain 101010 7 times, followed by the SFD 10101011. So this is a very unique pattern to indicate to the receiver end that there is a frame is following, and the receiver should be able to receive the frame in a proper way. So putting together, you have the payload, that is the packet or datagram from your network layer, and the frame is formed using the payload by embedding a 14 byte header and 4 byte trailer. So this is the formulation of the encapsulation in the sending side. Now you have a frame that is ready to transmit, and the frame will be converted into bytes, bytes will be converted into bits, and the bits will be pushed into the media. The media may be air in the wireless, or copper in the case of wired Ethernet, or light, that is optic signal in the case of fiber optic cabling. Therefore, the bits will be converted into proper form, depends on the media, and the media will carry these bits, and finally it will reach by the receiver. Bits will be converted into bytes, bytes into frame, frame into packet, packet into segment, segment into message, and finally the receiving applications will be able to process the message. So few more things I want to add, that is every the data link protocol will has a term called maximum transfer unit called MTU, and for the Ethernet 2 it is 1500 bytes, in which you have to think about if the frame is less than 64 bytes, we call them as a run frame, that is it is caused by collisions or malfunctioning of the network card or any buffer underrun or duplex mismatch or some kind of software issues. Then what is called a giant frame? The giant frame is any frame which is more than 1518 bytes, including the layer 2 header and the layer 2 trailer. Then what is a good frame? Anything that is from 64 bytes to 1518 bytes is called a good frame. Nowadays, due to the advancement in the network technology, some of the Ethernet standards were able to handle the frames with more than 1500 bytes. That is, your Giga Ethernet will be able to handle the frame with more than 1500 bytes. They are called jumbo frames. You have to enable your data link layer protocol to handle the jumbo frames, and the jumbo frames can carry up to 9000 bytes of payload. So with this, you have some idea about what is called a frame and how the frame will be handled by the data link layer protocol. And now we move on to the interesting things. So this is a byte dumped from the Wireshark, a network analysis tool from which you can clearly understand that the 003096052838 is nothing but your destination MAC address. So the destination MAC address is nothing but 0030960528 and 38. It is in hexadecimal, followed by the source MAC address, which is nothing but 003096E6FC and 39, followed by the type of the payload, which is nothing but IP packet. So you can see that 0800 is the type of the frame, which discuss that this frame contains a IP payload, followed by 45, where 4 is called the IP version 4, and the next 5 stands for the IP header is of standard size, that is of 20 bytes. And the most important thing is, we have a separate session on analyzing this bit by bit, but in this session you can see the source MAC address, the destination MAC address will be followed by the source IP and the destination IP. Therefore 08220001 marks the source IP, which is nothing but 10.34.0.1, and the destination IP is nothing but 10.1.2.1. So from that you can have a clear idea about how the MAC address and the IP address are embedded in the frame. So to have a better understanding, you can go to this URL to have a packet decoder. You will be able to get better understanding about the packet decoding mechanisms. So in this, the total entire frame, for your understanding, I had chipped them into different frames and other things. So if you look into that, this 5254007E42A5 is dealt with the destination MAC address, and the next thing shows the source MAC address, followed by the type of the frame, that is IP payload, followed by the version number IP version 4 with header length 20 bytes, followed by the source IP address. So look into that, you have C0A8380B, which is converted into the decimal, that is called the dotted decimal notation. So C0 is nothing but 192, A8 is nothing but 168, 38 in hexadecimal is nothing but 56, and 0B is nothing but 11 in decimal. Machine can understand only hexadecimal, whereas the human being will understand only through the dotted decimal representation. So this marks the source IP and this marks the destination IP. So we have, in addition to that, the MAC address and the IP address, we have the important protocol that is called the UDP or TCP. In this case, we have the user datagram protocol as the transport layer protocol. So the source port number is having 59198. So you can understand that this is a client source port which is greater than 49151. Keep in your mind, right? So in our case it is 59198 as a user datagram port address, and in the server side you have UDP port address as 53, which is nothing but the popular well-known port address called domain name services, DNS port number. So always the client will have a port number greater than 49151, whereas the popular services will have well-known port address which is within from 0 to 1023. In our case it is 53. So with this we come to a clear understanding that every networks will have the 7-layer architecture by default, in which you will have the MAC address in the layer 2, IP address in the layer 3, and the port address in the layer 4. So layer 2, layer 3, layer 4 constitute the addressing mechanism for smooth functioning of the internet communication. Address resolution protocol. The ARP in the networks plays the major role to find the MAC address when the IP address is known. For example, through the DNS server, you will be able to convert the name into number, that is domain name, into an IP address. So IP address is used to form the packet, but you need to have the MAC address to form the frame. After forming the frame only, the frame will be handed over to the bottom layer, that is the physical layer, for pushing into the media. Therefore, when you do not know the MAC address of the receiver, that is the destination, you need to have a mechanism to find the MAC address using the destination IP address. For that, the ARP will be used to convert the IP address into its MAC address. So, if you look into the picture, you can see that there is a local area network with 4 computers connected, and each is configured with an IP address, and the network interface card has a burned in address, that is nothing but the physical address or the hardware address or the media access control address. So if you take this machine, it is having 137.196.7.14 as its IP address with 58.23.d7.fa.20.b0 as its MAC address. Now the question is, if I do not know the MAC address of the receiver, I have to send a ARP request. The ARP request will have the information who is having the IP address, say 137.196.7.23, please respond. All the nodes connected in this LAN will receive this ARP request, but only the computer which has its IP address matched with the ARP request will respond by giving a ARP reply. So the ARP reply will contain 71-65-F7-2B-08-53 as its MAC address. So when the ARP reply is received by the machine who initiated the ARP request, will be able to map the IP address with the corresponding MAC address. Therefore, whenever a MAC address is learned, the ARP table will be populated with the parameters, that is the IP address, corresponding MAC address, followed by the time to live. By default, every MAC entry in the ARP table will have a default time to live of 20 minutes. So in that way, through the address resolution protocol, whenever I know the IP address of the any one machine, I will be able to get its MAC address through ARP request and reply mechanism, which is nothing but address resolution protocol. There is another interesting protocol called reverse ARP. The reverse ARP is to translate the MAC address into its equivalent IP address. So that is also useful in some scenarios where you know the MAC address but you do not know the IP address. So using the reverse ARP, you will be able to learn the IP address of the corresponding MAC address. Fine. Next, we are going to discuss about how the packet gets routed from one local area network to another local area network with the help of a router. Here you take that the node A is the source node and node B is the destination node. In between, the node A and B are connected through a router called R. So the router has two Ethernet interface. One is connected to the network 1 in which the node A is connected, and the second Ethernet interface of the router is connected to the another network to which the node B is connected. So the source node A is having an IP address 111.111.111.111, whereas the destination node B is having an IP address 222.222.222.222, and the node A is having a MAC address 74-29 and so on, whereas the node B has a MAC address 49-BD- and so on. Now the thing is, you all know that now when A wants to communicate to the B, it has to create a TCP connection from A to B. For that, you need to establish a connection from a socket in the node A to a socket in the node B, for which you need the source IP address and the source port number in the node A, and the destination IP address and the destination port in the node B. Now, you need only port number and IP address. Then what is the role of the MAC address? Fine. The MAC address is to route the frame from one interface to the other interface in the same local area network. So in this case, if you look into that, the node A has to push the data to the network to reach the destination B through the router R. Therefore, it has to form a frame. The frame will be formed with a source MAC address of its own MAC address, that is the MAC address of A, which is nothing but 74.29.9C, E8, FF and 55. Look at here, in general, we may thought that the destination MAC address will be the MAC address of node B, but it is not the case, because MAC addresses are visible only within the local area network. Therefore, in this case, to reach the node B, any packets from the node A has to reach the Ethernet interface E1, which is having a MAC address of E6E90017BB4B. Therefore, if you look into the frame that is formulated by the node A, it is having a MAC destination as E6E90017BB and 4B, which is nothing but the MAC address of the Ethernet interface E1 of the router R. Now, the frame is pushed into the local area network, that is network 1, and this will be received by the router, and in the router this frame will be processed through the physical Ethernet and the network layer. So now the frame is processed by the router, and now the router understands that based on the destination IP address, it understands that this has to be forwarded through the Ethernet interface E2, so that it will reach the actual destination node, that is B. Therefore, the router R now has to form a new frame with the source IP as the IP address of the node A, destination IP as the IP address of node B, and here the interesting case is the source MAC address will be different. Here the source MAC address will be nothing but the MAC address of the Ethernet interface E2 of the router, which is nothing but 1A23F9CD06 and 9D. So for the node B, the actual frame is formulated by the router R. It is not the frame actually from the node A. But the payload is same, only the frame headers and the trailer are different. Fine. So with this, it is clear that the MAC address is visible only within the local area network, and a new frame is formed, and the new frame is now pushed into the network N2. So the network N2 will now receive this frame, and the frame will pass through the media and finally reaches the destination node B, and the destination node B will understand that the destination MAC address is my MAC address, so I have to process this frame, and based on the CRC checksum, the validity of the, that is the integrity of the frame is verified, and based on the integrity, the frame will be removed from its header, L2 header and the L2 trailer, and after removing the L2 header and the L2 trailer, what we get is called the packet. The packet will contain the layer 3 header with the payload from the upper layers. So the IP source address will be 111.111.111.111, that is the IP address of node A, and the destination IP address will be the IP address of its own node, that is IP address of the node B, that is 222.222.222.222. And now the packet is ready to process and hand over to its upper layer for further process. So in this way, the frame will be routed from one network to another network via the router. So with this, you got clear idea about how the MAC addresses will be used in forming the frame. Only the frame or travel through the media to reach the destination. Now we are going to discuss about the usage of sockets to create the TCP connection. Server creates sockets and listens, client creates a socket and connects, transport layer delivers message to the server creates another socket and processes the request. The transport layer delivers the response message to the client, and finally the sockets gets closed. So look at here, the web server create a socket dedicated to listening for client request. After the socket exits, the server goes to the listening mode and wait for a client request. It periodically checks for messages received in the socket. This type of socket is referred to as a connectionless socket. This connectionless socket is used to establish a TCP connection with the HTTP server. Note that there is no destination IP address or port number defined for this special socket. So this is the listening socket. The transport layer is TCP, source port is 80, source IP address is 192.168.1.102, which is nothing but the IP address of the server. So this is the listening server and it is in the listening and open mode. The next is the client side. So in the client side, the client is hosted in the IP address 192.196.1.101 with the source port of 10378. The client will also make use of transmission control protocol in its transport layer, and it is going to establish a connection with the server. So you all know that the server is hosted in the IP address 192.168.1.102 and it is offering its HTTP service through the port number 80. So the next stage is the transport layer delivers the message from the client to the server. The client's transport layer periodically checks its transmit buffer to determine if a message needs to be sent. Whenever a message is found, it is forwarded to the destination address, which is nothing but the server. So now look into the screen, you can easily understand that this is the client socket and this is the server socket. The server socket is in the listening mode with a null in the destination port and the destination IP address. When the client request reaches the server will create another socket. That is more important, right? So the second socket is created. The second socket is created by the server and it will do the further process. So when the server receives the client request, it creates a new dedicated socket and process for this client request. It then creates a message for the client and send that message as a response to the socket. This socket uses the client's destination IP address and the port number. This virtual TCP connection is now referred to as established. So this is more important. Suppose if the server has 10 simultaneous client requests, then it will have 10 such a dedicated sockets with different destination IP address and corresponding port address. So look at here, you all know that this is the actual client socket. This is the server socket in the listening mode and this is the server socket in the established mode. So through this established socket, the server will be able to send a response message to the client based on the client HTTP request. So if you look into the established socket, you can understand that it has a destination IP address as well as destination port address along with the source IP and the destination IP. So in that it is very clear that through the connection, TCP connection established, the socket connectivity will have 4 parameters, that is the source port, source IP address, destination port, destination IP address. So these are all the 4 important parameters that is responsible to distinguish one TCP connection from multiple other TCP connections. In addition to these 4 parameters, it is also recommended to mention about which transport layer protocol is used in the transport layer. In our case it is TCP, therefore 80 belongs to the TCP, that is transmission control protocol. So the transport layer delivers message to the client. The server's transport layer periodically check its transmit buffer to determine if a message needs to be sent. Whenever a message is found, it is forwarded to the destination address, which is nothing but the client side. So look at here, the web page HTML file as a HTTP response will be pushed from the server through its established socket to the client, and that's all about that. Now the transaction is over, that is the HTTP request from the client to the server and the HTTP response from the server to the client is over. The business is over. Now they have to close their socket. Therefore after the client receives the web page, it requested, it sends an acknowledgement to the server, then closes its socket. The server receives the client's acknowledgement, then the server also closes the established socket. Now you can understand the client side socket is closed and the server side established socket is also closed. But keep in your mind that the socket in the server which is in the listening mode is always active, because the server is always active to listen another request from the same client or from other clients. So through this mechanism you will be able to understand that how the socket connectivity is established between the client and the server, and how the single server is able to provide the services for multiple client requests. Thank you.